All right, so continuing on with our Unit 2 Lesson 6 notes, we're going to dive into a couple of the examples that are on here. I'm not going to do every bit of it with you because you obviously need to practice, but I want to get you started and on the right foot. So, exercise 1 has the phrase two consecutive integers. So, that goes back to that n and n plus 1 that we were talking about earlier. Um, whose sum, so we know we're going to be adding, is. The word is always going to be a clue for an equal sign in equation type of problems. So the sum of these two consecutive integers is 11 less than 3 times the smaller integer. So the first example wants you to do some guess and check just to see if you could kind of figure out what these numbers might be. So we're going to start with 5 and 6, and then I'm going to let you fill in the rest of the table with your own guesses to see if you might be able to discover what these numbers are using the guess and check method. But let's try 5 and 6. So 5 plus 6, that's the sum. So that's 11. The sum is supposed to be 11 less than 3 times the smaller number. So the smaller number in our choices here is 5. So 3 times the smaller number is going to be 3 times 5. And then this 11 less than means minus 11. So minus 11. 3 times 5 is 15. Minus 11 is 4. So we got a sum of 11 and a sum of 4. Those do not equal each other. So is this a solution? No. 5 and 6 are not the solution we're looking for. So you come up with your own sets of consecutive numbers to try in these columns and see if you might come up with the combination that works. Some people do, but not always. So try it out. Okay, if you were lucky enough to figure it out using guess and check, leave me a comment or come tell me in class that you found it on the table. But if you haven't found it yet, then you have definitely seen that setting up a table like this, while it is useful to get a really good understanding of what this phrase wants you to do, this is not the most efficient way to solve a consecutive integer problem. Instead, let's go down here to part B and let's actually set up an equation using let statements and expressions for the two consecutive integers. So again, if you watch the vocabulary video that was before this one, then you know that when we're dealing with consecutive integers, we have a smaller and we have a larger. In this case, we only have smaller and larger because it's only two numbers. So the smaller number, we're going to let that equal n. That's going to be our let statement for the smaller number. And then the larger number, because these are consecutive, is going to be n plus 1. So when you set that up according to the information that we were given at the very top up here, their sum is 11 less than 3 times the smaller integer. Sum means we need to add these two together. So n plus 1. Get rid of this down here. And then that's their sum is, so equals 3 times the smaller is going to be our first thing. So 3 times n for our smaller. And then 11 less than that would be minus 11. So here's your equation. Go ahead and solve that to see what you come up with for n. Once you know n, that's your smallest, and then n plus 1 is going to be your larger integer. I'm going to pause the video and give you a second to solve that. Okay, so you solve the equation. Here are the steps, and then the solution is that 12 equals n, or n equals 12, meaning our smaller integer is 12, and so n plus 1 for your larger one is going to be 13. If you plug 12 and 13 in here and here, then you would be doing the sum of 12 plus 13, and then you're checking to see if that equals 3 times 12 minus 11. Whoops, there we go. Let me erase. Oh no. I didn't mean to erase that whole thing. It's going to be okay. you know what? One take. We talked about this earlier when I introduced this to you. Let me set that up real quick. It was 13 and 12 being added together. And then we had 3 times 12, the smaller, minus 11. I was just trying to erase a parentheses and I cleared the whole screen. So let's see if these do in fact equal each other. 12 plus 13 is 25. And then 3 times 12 is 36, minus 11 is 25. So that step right there is definitely not one that is required when you're solving consecutive integer problems, but it's not a bad idea just to confirm that the numbers you came up with do in fact meet the criteria that was listed in the problem. All right, you're gonna go to the next section of the notes now and try those on your own. The next ones do mention an odd integer, if I remember correctly. Let's look real quick. Let me clear the screen for real this time. Okay, so if oh, let me go back. There we go. Yeah, so we got odd integer right there. I'm struggling. Here we go. Odd integer refer, if you go back to your vocabulary notes on that, that's going to be where you're adding 2 each time. And then the next ones that I want you to do, watch out for those, the vocabulary in those. We've got 3 consecutive even, so that's going to be that +2 again, and 4 consecutive, so +1s. So when you're setting up your equations on the next 3 examples, just be sure you're paying attention to that vocabulary there. All right, give those a try and then come see me when you're finished. Obviously,